Zhang. He's a PhD student from University of London, and his title is GrACE, a generative approach to better confidence elicitation in large language model. Let's welcome Zhaohan.
Hello everyone. I'm glad here to share our work about confidence elicitation. And this work is done with collaboration with Ziquan Liu and Yanis Patras from Queen Mary University of London. First, I will briefly introduce the confidence elicitation and calibration. So, given the sampled responses from a language model given the prompt, we want the confidence to be a score estimator for each sample yi from the response set y, and we want the confidence to provide an effective and reliable indicator for the factuality of the model responses at test time. So, given that purpose, we would like it to have two properties. The first is the discrimination. It means that the confidence score should exhibit strong separability between the positive and the negative sample. And the other is calibration. It means that the confidence score should align closely with the actual correctness with the response. Given the desired properties, we have some metrics to evaluate it. So the first metric to evaluate calibration is the expected calibration error (ECE), which is the average of the weighted sum of the group accuracy and the average confidence. And for evaluating discrimination ability, we use this kind of common metric AURC. Which measures the probability that the model ranks a randomly chosen positive sample higher than the randomly chosen negative one. And that gives some cases to illustrate that both calibration and discrimination are important for evaluating the quality of the confidence. If we only have calibration without discrimination, there can be some corner cases where the model only outputs a single value represents the average accuracy on the data set. So in this case, the confidence score doesn't mean anything and is not usable. And if the confidence score only exhibits the discrimination but without calibration, the value of the confidence could be unreliable. So we want the confidence score to achieve both the calibration and the discrimination, and finally achieve this perfect calibration. Okay, so after the background, let me introduce our work about confidence elicitation. So there are roughly like two categories about the work on confidence elicitation. The first is the post hoc method, which requires an additional confidence evaluation stage after the generation of the response. It brings a high latency. And another is the verbalized method, which asks the language model to express its confidence about the response like in the form of natural language. But those methods are usually not calibrated. And in our work, we propose this method, GrACE, that produce the calibrated confidence in real time. In our work, we append a special token at the end of the model response, and we align the probability of this special token to the accuracy of the response to solve the drawbacks of the previous two categories. Okay, here's our method framework. To calibrate the model, we need to first have a calibration set to achieve this. So to construct this calibration set, we first probe the models that's their hidden state to first get an uncalibrated score, and we assign this score S to each data point that is the question answer pair using k-fold validation, and then we group the data to the bins with equal interval according to the X, and we calculate the accuracy for each bin as a calibration target T. In this way, we assign the calibration target as the response accuracy. That is what we want to achieve in calibration. And during training, as I mentioned before, we want to add this special token at the end of the model response. So we first append the special token to the end of the response in the training data set, and use supervised fine tuning to teach the model to produce the response like in this format. And then we align the probability on the special token with the calibration target using the MS-ELAS. That can be seen as like minimizing the expected calibration error I introduced before. And here we only train the embedding of this special token and a set of lower parameters so that it's kind of like lightweight. So after we have done that, we are wondering that instead of a passive indicator of the response quality, can the confidence become an actively applied to the engineering practice. So and we found a good application scenario here, which is test time scaling. I think that shares some share the same thoughts with Zhengxun's work. Test time scaling repeats the sampling in the inference stage with decision rules to select high quality samples for given prompts. So like assuming that we already have the calibrated confidence, and apparently this confidence could be applied into this decision making process. And we designed two strategies to achieve this. First is we incorporate the confidence score into the self-consistency strategy, and using the weighted sum of the frequency of the response and the confidence. And the other is the early stop strategy, which early stops the sampling process when the confidence score meets a predefined threshold. Okay, here's our experiment. First, we test if our confidence is calibrated in the open-ended generation task, where the answer space is unconstrained, and we found that our method performed the best in this open-ended generation task and generalize well to unseen domains. And as for the test time scaling, our work boosts the performance and the efficiency of the current test time scaling strategy based on self-consistency. And we also test if the confidence produced by our method is a good indicator for the test time scaling compared with other confidence estimation methods. And we found that our method is best calibrated, and better calibration helps the performance of test time scaling. Right. Thank you for listening.
Any questions?
Yeah.
In the back, why can I improve why can I do calibration with the integration?
Cool. That's a good question. So here, So first, our motivation is that we want to get the confidence score during the generation stage of the model. So we append this token here, as that after the generation we can quickly get this token, right? And we align the probability of this token to the target we set here, which is a response accuracy during training, so that every time we got this token, we calculate its probability, and we get the confidence score that is calibrated.
I basically had the same question. I was wondering why you're outputting a single token and you're not training to output the probability, the confidence score as a number.
Sorry, so I don't quite understand. Is that, are you asking that why I append this token here and get?
Yeah, it seems to me the token can be appended or not appended with a given probability. Is that right?
Actually, here is that. So usually our confidence score is like between 0 to 1, right? And usually it's like 0.1, 0.2, 0.3, something like that. It's not very trivial, but considering the large vocabulary, this probably is usually non-trivial and can always be sampled at the end of the response, given that we already trained it with supervised fine-tuning. The model has learned that it should produce the response in this format, so it can always be appended at the last.
Okay, thanks.
Thank you.
Thanks, Zhaohan, again.